In this module, this will be the last module that actually covers a specific statistical analysis. What you'll need open is the Year 8 ANOVA Chi Core database. That's in the K-12 database, the Year 8 ANOVA Chi Core database. And you'll need open outputs number 19. The specific analysis that I'm ultimately going to talk about here is called a Chi Square. But before I do that, I'm going to get back to a descriptive statistic that I want you to be able to interpret. They're just cross tabulations. And what I want you to do in ANOVA Chi Core 8 is I want you to go up to Analyze, Descriptives, again, Descriptive Statistics, and I want you to click on Crosstabs. And under Crosstabs, let's make the row gender, and let's make the column SES group. And what I want you to do is go over to Cells to the right of those two boxes and find percentages, and I want you to click on row and column and do continue and then OK. And I haven't run a statistical test. I've just basically displayed, again, crosstab statistics, which are nothing more than frequencies in a 2x2 or a 3x2 or any combination of numbers of cells. So you have to have categorical variables. They can be ordinal or not. Most often they're not. So I have two variables, paid lunch or free reduced lunch, that we've called SES group. And then I have gender and your female or male. And I've just basically said, cross those, form a 2x2 table. That's a crosstab. And the most critical thing to be able to do, and this is a little bit tricky, is to interpret these different numbers. In the top left cell, what you would do is you see the first number is the count. You have 194 students that are female and eligible for paid lunch. You have 546 students who are female and free reduced lunch. You have 529 males who qualify for free reduced lunch out of your total sample. So if I add up the number in each of these four cells, I'll end up with 1,500 students. So it's a 2x2 because there are two groups under free reduced under SES group, paid lunch or free reduced, female and male, 2x2. So I have four cells. If this was religion and I had three different religions, I would have a 3x2. The trickier numbers to read here are these percentages. And what you need to do is you need to realize the difference between what's called a row percentage and a column percentage. The percent within gender, in this case, is called a row percentage because you'll see that across from gender, the two options add up to 100. So the top number, percent within gender, the row will add up to 100. For the bottom number in each cell, the column adds up to 100. So those are referred to as column percentages. 45.6 plus 55.4 equals 100. So to interpret a row percentage, you start with, of all of the group in that row, in this case, of all females, what percentage qualify for paid lunch? And it's 26.2%. Of all females, what percentage qualify for free reduced lunch? 73.8%. So where do we get these numbers? There's a total of 740 females, 194 qualify for paid lunch, 194 divided by 740 equals 26.2%. 546, roughly 3/4, qualify for free reduced lunch. So the key here is I might ask you, of all males, so I would go down to the male row, what percentage qualify for paid lunch? You would go across from male, you would see that there are 529, or 69.6%, that qualify for free reduced lunch. 30.4%, or 231 of the 760 males qualify for paid lunch. Where this gets a little confusing is I could start with the column and I would ask you a very different question. Of all the students in this sample, what percentage qualify for paid lunch? Then you start with, of all paid lunch students, what percentage are female? So I say, of all paid lunch, I'm in this column, what percentage are female? I go down to the second number, the column total, and it's 45.6%. So people often get confused with which of these two percentages to interpret. And the key is it across the row that adds up to 100, or is it down the column that adds up to 100? And if it's across the rows, then I'll say, of all of a particular group in the row side, for example, of all females, what percentage qualify for free reduced lunch? I go across female to the free reduced lunch column, and it's 73.8%. If, on the other hand, I said, of all students in the sample who qualify for free reduced lunch, what percentage are female? Then I start here, I go down to the column total, and I look across for females, and it's 50.8%. So, of all paid lunch students, what percentage qualify for, of all paid lunch students, what percentage are male? 54.4%. Of all males in the sample, what percentage qualify for paid lunch? 30.4%. So that's the difference between column and row totals. It's simply reading percentages, but they're difficult because you often see both row and column totals in the table. So the next question is really to move beyond simply the descriptive statistics and to run a test that's called a Chi Square. A Chi Square test really is the single test that we cover that doesn't fit into my flow chart that I gave you at the beginning. It's a non-parametric test. And what you're essentially doing to determine if you need to run a Chi Square is you're asking yourself two questions. The first one is, do I have these two categories, two categorical variables, not continuous, that basically can be divided into two non-ordinal groups or two ordinal groups? And then secondly, the actual research question is, are these two groups independent of one another? The appropriate language is, again, are they independent of one another? So if I want to know if gender and free and reduced lunch rates are independent of one another, I'm going to go back to my analysis, descriptive, crosstabs, and you'll see statistics. We've already got our row and column percentage, but we haven't actually run a statistical test. And all I need to do is click on it, find Chi Square, click OK, and this time the output at the bottom of it adds the Chi Square test. And the number that matters, really the only output that matters in this case, is this one. You'll see Pearson's Chi Square, and that's the significance value, that's the p-value. And because that value of 0.073 is greater than 0.05, that's not statistically significant. So I can't conclude that gender and free reduced lunch rates interact with the number in some way. In other words, they are independent of one another because the test is not statistically significant.